Today we're going to talk about the second half of operations with functions, section 9.4.2. So the second half of operations with functions. Continuing on, we'll review a little bit what we did with 9.4.1, but now it's the second half of that, which is still operations with functions. So this is a review from what we did last time. Given f of x equals 4x squared minus 1 and g of x equals 2x minus 1, find each function. Recall f plus g of x, that is the same thing as f of x plus g of x. So I'm just going to combine like terms with respect to addition. And when I add them, combine like terms, I'm going to get 4x squared plus 2x minus 2. Because I cannot combine the 4x squared and the 2x. The negative 1 plus negative 1 is the only thing I can really combine. Same thing on number 2. Remember, f minus g of x is the same thing as f of x minus g of x. Well, f of x is 4x squared minus 1 minus 2x minus 1. Now, some of you might want to do well with that subtraction sign. Distribute it or change subtraction to addition. Either way you work it out. I now get 4x squared minus 2x, and that is it. What happens with those negative 1s? They cancel because it's negative 1 plus 1. Then you give me a 0. End up with 4x squared minus 2x. Number 3, f g of x is the same thing as f of x times g of x. F of x is 4x squared minus 1 times g of x is 2x minus 1. What process would I need to use to multiply here? I would have to FOIL. First, outer, inner, last. And when I FOIL, I get an answer that looks something like 8x to the third minus 4x squared minus 2x plus 1. And then the last one, number 4. F over g of x, that's the same thing as f of x over g of x. F of x is 4x squared minus 1 over g of x, which is 2x minus 1. I can factor the numerator here. Does anybody know what 4x squared minus 1 breaks down as? It's one of those difference of squares problems. It is 2x plus 1 and 2x minus 1. Difference of squares mean because one's addition, one's subtraction, same thing. All over 2x minus 1. What cancels out here then? The 2x minus 1. Leave me with 2x plus 1. And x cannot equal 1/2. And again, why can x not equal 1/2? Because that's where I get 0 in the denominator. Alright? So that's what we did last time. Today we're going to talk about composition of functions with respect to the actual functions. So last time we talked about plugging a certain number in, substitute it in, get a number back out, substitute that value in. Well, today we're talking about just the functions themselves. So notice they have f composed of g of x. It's the same thing. They're not having a number in there. So for instance here, I take my inside function and I'm going to substitute it into my outside function. So f of g of x means I'm going to take my g of x function and plug it in for x in my f of x function. Again, we see that here. They substitute it in. From there, you would distribute and simplify to get a final answer. Same thing, I can go the other way. If I want to go the other way, I could take the f of x function and plug it into x for g of x. Notice here they had 3x plus 2 squared. Well, anytime I have a squared term means I have to FOIL because it's times itself. So I'd FOIL then and simplify. Notice when I compose them of different functions, they do not get the same answer. So they are not commutative. They would not be the same thing. All right. So let's try number 5 here. Given f of x equals 4x plus 1 and g of x equals the square root of x plus 3. Find f of g of x. So I'm going to take my inside function here, which is g of x plus 3, square root of x plus 3, and I'm going to plug that in for x in my other function. So notice they substituted it in down there. So I get 4 parentheses square root of x plus 3 plus 1. Now what am I going to have to do? Anytime I have a number outside of parentheses, I want to distribute. So that gives me 4 square root of x plus 12 plus 1. And now I simplify, getting me 4 square root of x plus 13. Notice that 3 and that 12 were outside of the radical, so I could combine them with the 1. Does everybody see that? Yep, and that's my final answer today. So I'm just going to simplify them down. Let's do part B here. Well, part B says take f of x and plug it into g of x. So I'm going to take f of x and I'm going to put it into g of x. So that gives me the square root of 4x plus 1 plus 3. Can I combine the 1 and the 3 here? No, why not? Yep, the 1's inside the radical, the 3 is not. There's your final answer. Let's try. Let's try number 6. So given h of x equals 2x minus 1 and k of x equals 3x squared, find h of k of x. So which function am I plugging into the other function? I plug where? I take k of x and I plug it into h of x. So that's going to give me 2 parentheses 3x squared minus 1. What do I do next then, Maddie? Yeah. Wait, what? What's 2 times 3? Yeah.
6x to the second minus 1.
So I get 6x to the second minus 1. And that is your final answer. There's no other like terms. Nice job. Let's try B. What's different about B? Now I'm taking h of x and plugging it into k of x. So now I take h of x and plug it into k of x. So I get 3 parentheses 2x minus 1 squared. What does it mean to be squared? It means that I take it times itself. So it's 3 parentheses 2x minus 1 times 2x minus 1, which means now I need to FOIL, first, outer, inner, last. When I FOIL, I get 3 parentheses 4x squared minus 4x plus 1. And then lastly, I would need to distribute the 3, giving me 12x squared minus 12x plus 3. Nice job. Yes, sir.
Are we gonna ever have anything larger than a binomial? Like for the
You might have a trinomial. Like a binomial and a trinomial. That's about as large as it'll get. I don't think they'll have anything larger than that, though. Alright, take a couple seconds to try these 6. These are a review of what we did last time. So now you're doing the actual numbers here. So number 7, make sure you plug 9 in for K. Take that answer, plug it in for G. Take a couple seconds to try these 6. Number 7, G of K of 9. What do you get when you plug that one in, John?
first one?
Yeah.
It's got 9 yet.
It is 9. Number 8, H of G of negative 3. What do you get when you plug that one in, Maddie? 1. Nice job. Number 10, G of H of negative 3. What do you get when you plug that one in, Andy?
I got 120.
121. Good work. Number 11, F of G of 4. What do you need to plug that one in, Jack?
At 1 over 52.
1 over what?
32.
32. Correct, sir.
Yeah, I'm sorry.
Number 12, K of H of 12. Where do you get when you plug that one in, Maddie? Number 12?
2.
It is 2. And 13, F of H of 1. What do you get when you plug that one in, John?
14. Because 1 times 8 equals -7 times 2. Then we have to not have a negative.
Negative 1/14th? You're thinking of exponents, I think. Right? Because you get negative 7, you plug negative 7 down below. 2 times negative 7 is negative 14, so you get negative 1/14th. Yep. Alright, same idea, same functions. Now I want you to composite them, or compose them with respect to x. So take number 14, take g of x, x squared, and plug it into x for h of x. Alright? So take a couple seconds to try these.
I tried to do it.
Math related riddle. Is that what this
No.
is?
Number 14, h of g of x. What do you get when you plug that in, John?
X squared minus
Yeah, you get x squared minus 8. And then number 15, k of g of x. What did you get, Maddie?
X.
You get just x. Because you take g of x, plug it into k of x. So you get the square root of x squared, which is x. Nice job.
You have to
Take a couple seconds to try the next two. Same idea, using the same functions.
But really, I'm just
All right, let's try this here. 16. What's f of h of x? What did you get, Andy?
1 over 2x minus 16.
Nice job. What can x not equal here, sir?
8.
X not equal 8 here. Nice job. And number 17, h of g of x. What do you get h of g of x, Jack?
X squared minus 8.
X squared minus 8. Good work, sir. And that is it for today.